Namaste everyone and welcome back. In this video, we are going to solve the problem binary array sorting. This is a simple but very useful problem for understanding the two-pointer technique and in-place array manipulation. Let's first understand the problem. We are given a binary array and binary array means that every element is either 0 or 1. For example, 1 0 1 1 0, like the first example you can see. Our task is to arrange the array in increasing order. We have to rearrange the array in increasing order. Since 0 is smaller than 1, all the zeros should come first, followed by the ones. So, given array is uh, 1 0 1 1 0, it should become this 0 0 1 1 1. The important condition is that we must modify the same array. We should not create another array. So our solution must work in place and use constant extra space. Let's understand the pattern. Observe what a correctly sorted binary array looks like. It contains all zeros on the left side and all ones on the right side, like this 0 0 on the left side and the right side 1 1 1. And in this output 0 0 0 1 1 1 on the right side. Now imagine that the array is not sorted. There must be a 1 on the left side that should move towards right. There may be also a 0 on the right side that should move towards the left. So whenever we find a misplaced 1 on the left and a misplaced 0 on the right, we can simply swap them. So this observation leads us to the two-pointer approach. So we will use two pointers. The first pointer is called left, like we can see here. L is for left pointer and it will start from index 0, and the second pointer is called right, that is here R, and it will start from last index of the array. The left pointer will move towards the right. And its job to find a one that is incorrectly placed on the left side. Like in this array, we can see that in zeroth position there is a one that is misplaced. It should be on the right side, and the right pointer will move towards left side, and its job to find a zero that is incorrectly placed on the right side. Like we can see that in the fifth position, sorry, like we can see in the fourth position there is a zero and it should be on the left side. When we find both, we swap them. After the swap, the 0 moves towards left, the 1 moves towards the right. Then we move both pointers and continue the same process. We stop when the left pointers meets or crosses the right pointer. At that point, the array will be sorted. Like for example, this left pointer, we can see that 1 is in a wrong position and 0 is also in a wrong position. We will swap them. uh, I am swapping 0 and 1, 1 in place of 0 and 0 in place of 1. Now it is swapped and left will be increased. Here is left and right will also decrease. And when the left will cross the right pointer, then our array is sorted. So let's write the solution. I am initializing left pointer from 0 and right pointer to the last position of the array. When left pointer will cross right pointer, or they will meet, the loop will be uh, exit. Now, if the element at left is already 0, it is correctly placed. So we move left forward. And if the element at right is already 1, it is also correctly placed. So we move right backwards. After skipping all correctly placed values, if left is still smaller than right, then the element at left must be 1 or the element at right must be 0. So we will swap them. So when left is smaller than right and left element is 0, then we will move left pointer to the forward direction till it not get a one element. And while the right element is 1, move right backwards. And if left is still smaller than right, we will swap the two elements. Then move both pointers inward. That is the complete logic. So let's quickly understand what the code uh, executes. In this loop, the first inner loop checks whether the element is at left is 0. If it is 0, then it is already in the correct section, so we will increase left. And the second inner loop checks whether the element at right is 1. If it is 1, so it is already in the correct section, so we will decrease the right pointer. After these two loops, if left is smaller than right, then we have found a 1 on the left and a 0 on the right. So we'll swap them. And in Python, swapping can be done directly using this uh, line. After swapping, we will move the left pointer forward and the right pointer backward. We don't need to return anything because the problem asks us to modify the input array directly. Don't need to return anything. Now we will dry run uh, an example. Let's take this array as an example. So we will dry run the this solution in this example in this array 10110. The indices are 0 1 2 3 4, and initially left is 0, right is 4. The element at index 0 is 1, and it is misplaced because 1 should be on the right side, and the element is at the index 4 is 0, and it is misplaced because 0 should be on the left side. So we'll swap them. The array becomes like this: 00111. Now we will increment left, so left become 1, and we will decrement right, so right will be 3. Now the element at index 1 is 0, like we can see. So we will move left to index 2. The element at index 2 is 1, it is correctly placed. So we will move the right to index 2. So left and right at the same position, and at both index 2, the loop stops and the final array is 0 0 1 1 1. So this is required sorted array. We will again do a dry run on the second example. Initially left points to the first element, which is 1, and right points to the last element, which is 0, and though both are misplaced, so we'll swap them. 1 become 0 and 0 become 1, and like previous we will move the left pointer to the right. Whenever the left pointer finds a 0, we will skip it, because in this loop we can see that if left pointer finds a 0, it will again increment. So left is left left pointer element is 0, it will go to the next element. Now right will be decrement by 1, so right will be here. Now we can see that in the left pointer there is element 1, and right pointer there is element 0. We will again swap it. Now left will be increased by 1 and right will be decreased. Now right pointer has found a 0 element, and that is misplaced. We will again swap them. Now left pointer will go forward. It has found one element. Now we will decrease the right pointer. Now here the element is again 1, so we'll decrease again. Now the element is 1 again, we will decrease again. Now left and right pointer has meet at the same index. Then the loop will end and we have found our sorted array. Everything the algorithm works because it maintains a simple rule. Everything before the left pointer is already correctly placed at 0. Everything after the right pointer is already correctly placed at 1. The only unsorted portion lies between the two pointers. When we find a misplaced 1 on the left and misplaced a 0 on the right, we swap them, and they go on the right regions. Therefore, the unsorted portion keeps becoming smaller. Eventually, the pointers meet or cross, and the entire array becomes sorted. Let's run and submit the solution. Now let's analyze the time complexity. Each pointers moves only in one direction. The left pointers move from the beginning towards the end, and the right pointer moves from the end towards the beginning. No element is processed many times, therefore the time complexity is big O of n. Now let's analyze the space complexity. We use only two integers variable like left and right. We don't we do not created any extra array. Therefore, the extra complexity is not there. So space complexity will be big O of 1. The final complexity is time complexity is big O of n, and space is big O of 1. There is also an alternative approach, that is counting. Uh, there is another way. We can first count how many zeros are present in the array. Suppose there are three zeros. Then we can override the first three position with zeros. After that, we can fill the remaining portions with 1. Like in this array, we will first count the zeros. Like there is 1 0, 2 0, 3 and 4 zeros. So what we will do, we will overwrite the four positions of the array with 0, and after that we will fill 1 in the second area. This approach also takes big of n time. Let's quickly look the how the code will look like. This approach also takes big of n time and big of one extra space. However, the two pointer approach is useful because it teaches us how to partition an array in place by swapping misplaced elements. This same pattern can later help in solving other problems like negative and positive numbers, even and odd numbers, zeros and non-zeros, and the Dutch national flag problem. Now let's discuss some edge cases. The first edge case is when the array contains only ones. For example, 1, 1, 1, 1, 4 ones. The right pointer will keep moving left because all the ones are already correctly placed. So no swap needed. The array elements remains unchanged. And the second edge case is when the array contains only zeros. For example, 0, 0, 0, 0. In this case, the left pointer will keep moving right because all zeros are correctly placed. Again, no swap is needed. The third edge case is when the array is already sorted. For example, 0, 0, 1, 1. In this case, both pointers simply skip correctly placed elements. The fourth edge case is an array of size 1. For example, only one element like 0. In this case, left and right pointer both point to index 0. The loop will not execute. The array is already sorted. Now some common mistakes we can make. Let's discuss them. Let's discuss them. The first mistake is creating a new array. The problem asks us to sort the array in place, so creating another array is unnecessary. The second mistake is forgetting to check that the left is smaller than right inside the inner loops, because without these conditions a pointer may move beyond the other pointer and cause an index error. The third mistake is returning the array. The function is expected to modify the original array directly. There is no returning any array is required. The fourth mistake is using built-in sorting without understanding the pattern. Using array.sort may work in some environments, but it does not demonstrate the intended in-place linear time approach. The fifth mistake is moving pointers incorrectly after swap. After swapping, both positions become correct. Therefore, we should increment left and decrement right. Let's do a final recap. We are given an array containing zeros and ones. All zeros should move to the left and all ones should move to the right. We use a left pointer and a right pointer. The left pointer searches for a misplaced 1 and the right pointer searches for a misplaced 0. When both are found, we will swap them. We will repeat this process until both pointers meet or cross. The time complexity will be big of n and space will be big of 1. And the array is modified in place. That completes the solution for binary array sorting. Now try solving it once without looking at the code and make sure you perform a complete dry run on the paper. Thank you for watching. I'll see you in the next problem.